Very good afternoon to all. I found one query was there regarding exercise 5.2. After question number 5 it was asked ki solve all the questions. So already question number 6 I have discussed with you. So I am picking today the last question, that is the number 9 question, and only 2 left, then 7 and 8 you can go through. Try it. So today again I will try to make you people understand ki how to read the pie chart. These 4 questions are based upon of the reading part of the pie chart. But to draw the pie chart and to read the pie chart, the key idea is very common. You see that angle at the center, somewhere whatever the angles are given to you, is always equal to value of one item, that is a single item, divided by the total and into 360. So this is the key idea, whether you have to draw or whether you have to read. Now this is the figure given to you in question number 9, and your question is, I will read out the question here. The following pie chart shows the number of students admitted in the different faculties of college if 700 students are admitted in commerce. So number of students in commerce is given to you, that is equal to 700. So this is also given. Answer the following. So your first part, what is the total number of students? What is the total number of students? Means somewhere I need to focus my attention over here. So first part, I want to find the total students there. So use this part, whatever is given to you, that is commerce. So here I have to see in my pie chart where commerce is there. So angle for commerce at the center, and I have to replace the value there, is equal to 70 degree. Is equal to value of one item. Value of one item means number of students in the commerce. One item means, now I'm speaking about commerce only, and the information about commerce available with me, there are 700 students. What I need to determine? Total value. Total means I need to determine total number of students. Take that is equal to x and into 360. So that will give you the total number of students. Do the cross multiplication. So 70 into x will be equal to 700 into 360. So your x will be equal to 700 into 360 upon 70. So you just cancel it up. So it means 3600 students are there in all. So that is the answer for your first part. What is the total number of students? What is the ratio of the students in science and law? So science and law. So when you are looking for science, here is the value. This is science. So you put the angle 110 degree. Now you need to calculate the one item. Put that is equal to y. Upon total, now you have got is equal to what? 3600 into 360 into 360. So again I am coming back because my concern is with science. I want to find how many students are there in science. Means these were given to you. Now I have to determine in science. So I will assume that only. So let the number of students in science is y. So angle at the center in case of science is 110. Number of students I have assumed here is y. Out of total, now total I have calculated 3600 into 360. So this makes it 10. If you will cross multiply, so y is equal to 100 into 110 into 10. So 1100 students you will be finding there in science. Similarly, you can go for the students in law. So law, the angle is equal to what? 50 degree. So 50 again is equal to, now suppose number of students in law is Z. Out of 3600 into 360, again you cancel it up. So Z will be equal to 50 into 10, that is equal to 500 students are there. And the ratio you can calculate 1100 upon 500, so it will become 11:5. So in that way you feel comfortable somewhere. Don't be panic anywhere. Take your time to understand. Somewhere try to focus upon this part. What is the angle at the center? What is the meaning of this one item? What is total? And why we are multiplying by 360 as the sum of all the angles at the center of any circle is always equal to 360 degree. So I hope that will make the topic clear. Whomsoever query was it, feel free to come to me. Again, you can send a comment if it is not clear. I can take another discussion with you. Don't feel bad to have the queries. And now I will go back to your algebraic expression what I started yesterday. And yesterday I have shared the definition of algebraic expression, that any expression which we are writing in terms of variables, coefficients with all four fundamental operations is the algebraic expression. I have explained it to you. What is your variable, what is your constant, what is the coefficient, what are the like terms, what are the unlike terms. All these things you need to take care of. And then I asked to please solve few questions of your exercise 9.1, at least 4 questions, because I have covered that part. What are the like and unlike terms, and these 4 questions are based up to your addition and subtraction, or find the number of terms, or classify the monomials, binomials and trinomials. So in first and second question I don't think any difficulty will be there, but in question 3 and 4, suppose one part I am picking up from this, as it is the fourth part of your question number 3. So if any problem in any part is there, you please send a comment to me. I'll come back to you with that particular part. Feel free to have your queries. So here it is. So the first term is given L square plus M square. Whenever the comma is there, you need to separate these terms. Then second is your M square plus N square. Third is N square plus L square. Fourth is 2LM. So fourth is 2LM plus 2MN and plus 2NL plus 2NL. So these are the terms given to you, and I need to add this. So you see somewhere, if I see L square, these are the like terms. So L square plus L square, you can club together like terms. Then it is M and N plus M square plus M square. You club these together, again like terms are there. And then N square plus N square, again N square plus N square are the two like terms, can be added. These all are unlike, so we have to write as it is 2Ln plus 2Mn plus 2NL. So finally your answer somewhere will be 2L square plus 2M square plus 2N square plus 2Lm plus 2Mn plus 2NL. If you want to take 2 common, only once you can write 2, and remaining all these M square plus N square plus L square plus Lm plus Mn plus NL you can write inside the bracket also. So you have to make it very clear that what I need to do while I'm adding in algebraic expression, I need to sort out the like terms, arrange those systematically, and if you want to go for the column method also, you are most welcome. But as you are climbing up to the higher classes, please make sure try to make best use of these brackets and solving brackets, so that you can become perfect in BODMAS also. That will definitely help you a lot in your coming classes also. So one question I will be picking from fourth, that is one part from subtraction point of view also, and the remaining I have left to you, but still if any doubt is there, you please clarify the same through your comments. So here it is, fourth part again I am taking from your question number 4, that is somewhere you have to subtract x upon xy upon 5 minus 35 upon 4 yz plus 7 upon 5 xz from you have to 4 upon 5 yz and then minus 6 upon 7 xz. So my suggestion to you, whatever you want to subtract and from which whatever is given to you, please put those inside the bracket. And when you are starting your solution, mark the sign of equal to and from. You will write that first. 4 upon 5 yz minus 6 upon 7 xz, minus sign is there, and write this inside the bracket again. Xy upon 5 minus 35 yz upon 4 plus 7 xz upon 5. Will not make a difference if I am writing these xy, yz and xz in numerators. One is the same thing. Now you open the bracket. So 4 upon 5 yz minus 6 upon 7 xz. As you know that when minus sign is there outside the bracket, you need to change the sign of remaining ones. So minus xy upon 5, this minus will change to plus. that is 35 upon 4 yz, and this plus will change to minus 7 upon 5 xz. Now please club the like terms. Yz with yz, 4 upon 5 yz plus 35 upon 4 yz, and xz is there, so this is there, minus 6 upon 7 xz minus 7 upon 5 xz, and finally your this xy is alone there. Yz I have clubbed with yz, xz I have clubbed with xz, no other term is, so write it individually, minus xy upon 5. Now here you can, in these two you can take yz common, and inside the bracket you will be left with 4 upon 5 plus 35 upon 4. Then in these two, if you want to take minus common, you can take minus xz common. So inside the brackets you will be left with 6 upon 7 plus 7 upon 5. So minus minus, I have taken minus common, but it is not necessary that you have to take common. If you will be taking plus xz, that will also work out, but then you need to put minus sign with both 6 upon 7 as well as 7 upon 5, and minus x upon y, xy upon 5 will remain as it is. Now you can solve the brackets comfortably, that is yz into 5 and 4, 20 is the LCM here, so this will be 5 4s are, so 4 4s are 16, plus 4 5s are 175, minus, here it is xz common, inside the bracket 35 will be the LCM, and 30 is here, plus 49 is here, minus xy upon 5, and then solve the brackets. Yz into 191 upon 20 minus xz, that is 79 upon 35, and minus xy upon 5. So finally you are getting your answer 191 upon 20 yz minus 79 upon 35 xz and minus xy upon 5. So you just can keep a check upon your answer also, and keep on trying these questions, and then you can start with the concept of your multiplication also today even, because in multiplication you need to remember unlike surds can also be multiplied or divided. Unlike surds can also be multiplied or divided. So for that, any example like x into y you can write as xy, x into y into z you can write as xyz. So question number 5 is also of subtraction, you can do that, but question number 6 is of finding the product only. So product, now monomial with monomial, very simple, but laws of exponent will be playing very important role here. Suppose I am asking you to multiply 5x by 3x, what happens? Make it your habit, 5 into 3, take the coefficients first, x into x will make it x square. As you did in law of exponents, when the bases are same, no power is there, power is 1, powers will always be added. That is the funda we are using basically in multiplication of the algebraic expressions, or I will say the polynomials. 5x into 3x means 5 into 3. Signs also you need to take care. Plus into plus is always plus. Suppose I am saying minus 7x into plus 3y. So make it your habit, call it out, make it your habit. Minus into plus is minus. 7 into 3 is 21. X into y is xy. That is the answer. Because these are unlike sets, so I can multiply. So minus into plus is minus, 7 into 3 is 21, x into y, that is the answer. Suppose I am saying minus 4x into minus 5y into 3z. Now again, minus into minus is plus, plus into minus into minus is plus, and plus into plus is plus. I know my answer will be in plus only. Then you write all these terms for all these coefficients together. Once it is clear that minus into plus is plus means I am very much clear that in my answer plus sign only will be there. So then 4 into 5 into 3 and x into y into z will make it xyz. So that is 4 into 5 is 20 into 3. So I will be getting 6xyz. So this is, I am giving you the example monomial with monomial, monomial with monomial, monomial with monomial, monomial with monomial. So do not need to start immediately with the exercise problems. Try to practice of your own first. Now monomial with monomial is over. You can take monomial with binomial. Suppose I am taking a multiply x minus y. What happens now? I need to multiply a. A is a single term, is a monomial. X minus y, two terms are there, means a binomial. So how to go for this? Means I have to write a into x minus y. If no sign is there, understood that I am multiplying. But now I am taking the case of monomial, I am multiplying with binomial. So what I have to do is here, I have to multiply a with both. So when a will be multiplied, plus into plus is plus. So a into x will make it ax. Plus into minus is minus, and a into y is ay. And leave it here only. So now this is the example. Or 2x 3y minus 4z is the another example. Try to code of your own examples to make the concept very clear to you. That's why I said it takes time. You take your time to understand the basic concepts about the same. Plus into plus, plus. 2 into 3, 6. X into y, xy. Then plus into minus, minus. 2 into 4, 8. X into z, xz, and leave it here. So like this you practice today few multiplication of your own, or start with your exercise question number 6 at least today, and then I will come to you with more examples, few other basic concepts tomorrow. Till then, bye bye.